Today we're pleased to have Nicole Immorlica from Microsoft Research presenting communication with anecdotes. And the guest panelists are Annie Liang and Nageeb Ali. The format of this seminar is as follows. We have a 60-minute presentation with time for interim questions from the panelists, followed by a 50-minute Q&A session. We request all attendees to keep their microphones muted during the talk. However, please post comments and questions in the chat. There will be an opportunity to ask questions live in the Q&A session at the end. The talk is recorded. Before I hand over to Nicole, let me invite you to our next seminar, which is the last for this calendar year. Ian Ball from MIT will present Should the Timing of Inspections Be Random with Jan Knepfle, and guest panelists are Brett Green and Curtis Taylor. As usual, you can find more information on our website or by following us on Twitter. Thank you. Nicole, the mic is yours.
Thank you. And before I start, I realized I got a message that my internet connection is unstable. So if at some point you can't hear me, I think maybe Annie has my cell phone number and can like text me or something. I don't know. But, yeah.
Hopefully it's going to be okay.
Yeah. Okay. So yeah, apologies if there's tech issues. So I'm going to talk about communicating with anecdotes, and this is joint work with Nika Haghtalab, who's now at UC Berkeley, my colleagues at Microsoft Research, Brendan Lucier and Markus Mobius, and Divya Mohan, who is now at Tel Aviv University. So I want to talk about a communication game. And so we have a sender who talks to a receiver about some state of the world. And examples that you could have in mind are, say, politicians who might be talking to constituents about policy decisions that they've made or are trying to make. And maybe that you could imagine newspapers, for example, who are talking to readers about current events of the world. So this is a one-way, one-time communication from a sender to a receiver about some state of the world. And key features in the model are that there's some information asymmetry. So the sender knows more than the receiver about the state of the world. And we also we're going to study a setting with hard evidence in which the sender has some samples about the state of the world, some signal about the state of the world that's immutable. You can imagine this, for example, that newspapers and politicians are trying to get their messages across by assembling examples and factual statements that correlate with the state of the world. And then there's also an element of agency. So the reason that the sender wants to communicate is because the receiver is going to take an action and has agency over which action she decides to take. And her choice is influenced by her beliefs about the state of the world, and her choice of action also impacts the payoff of the sender. So to turn this into a game, I need to tell you about the information structure and the strategies of the sender and receiver. So the sender is going to have a signal about the payoff relevant state of the world. I'll give you a little bit more structure of that signal in a bit, but for now you can just think about it as being a signal. The sender also is going to make a strategic choice, which is a communication scheme, what I'll call a communication scheme. And this maps the signal of the sender to the information that the sender communicates to the receiver. The receiver, on the other hand, has an information structure, which is a set of beliefs about the distribution of the signal and the state of the world. And these beliefs get updated when the receiver receives the communication from the sender. And then the receiver strategic choice is to take an action, which maps her the information that was communicated to her to a payoff relevant action choice. And again, this action is payoff relevant for both the receiver and the sender.
Just to clarify, Nicole, does the receiver have information apart from what the sender communicates to the receiver? Okay.
The receiver is completely uninformed, so much so that I'm going to assume that the prior over the state of the world is a uniform prior. A diffuse prior. The agents are maximizing their utility and expectation over the state and signal. I'll make all of this formal in a model section in a bit, but I just wanted to give you a little bit of sort of background so that I can go through my motivation in a bit more detail. And finally, the way that the utilities depend on the action and the state of the world is based on ideal points for the sender and receiver. So the sender is going to have an ideal point that's some shift of the state of the world. I'll call that MS. When we started writing this paper, we called that moral, M for moral stance. I've since decided that I don't like the value implication of moral stances, so I'll just call these ideal points. And so the sender, throughout this talk, I'll be assuming that the sender's ideal shift of the state is something slightly to the left of the state of the world. So the sender would like the receiver to take an action that's a bit to the left of the state of the world. And the receiver would like to take an action that's a bit to the right of the state of the world. And these shifts are MS and MR. So in this example, MS is negative, MR is positive. What'll really matter is the gap between MS and MR. So let's think about these examples a little bit that I brought up in the first slide. We had politics. So we have a president and she will have some issue that she might wish to talk about with her constituents. And so she's going to say the issue, for example, is the gender wage gap, and she's going to do a bunch of research, or her team is going to do a bunch of research and collect stories from constituents about the gender wage gap. And then through her communication scheme, which might be her speechwriters, she'll select some of these stories to communicate to her constituents. And maybe she's trying to change, the actions of her constituents. So maybe she's talking to the employers who have some beliefs about the gender wage gap and are going to take an action, which is how much to pay different employees at their firm. And you could imagine that the president potentially values fairness over free markets more than the employers, and so maybe wants the employers to pay women more. So that's one example that I have in mind. Another is journalism. So here you could imagine that the sender is a newspaper and the sender wants to talk to the readers, the receivers are the readers here, about something like, say, COVID, the danger of COVID, and the effectiveness of wearing masks, perhaps. So the newspaper, the journalists are going to do a bunch of research into COVID, and they're going to then have an editorial policy. The newspaper has an editorial policy that will select different facts and different things to report on. And then the newspaper will come up with an article that the readers will read, and that'll affect the readers' beliefs about the danger of COVID and the effectiveness of wearing masks. And then the readers are going to pick an action, which might be the fraction of time they spend wearing masks. And again, you could imagine that the preferences aren't entirely aligned. Potentially, the newspaper might value global health a bit more over personal freedoms than the readers do. And so wants the readers to wear masks more often than the readers naturally would relative to the state of the world, which is the danger of COVID. So these are some examples. And what I wanted to emphasize in these examples is that naturally the senders are communicating in anecdotes. And this is going to be the main sort of thing that I study in this paper, which differentiates it from prior work. An anecdote here is something immutable, which I can include or exclude when I talk to you. And so in particular, I'm now going to insist that the signal of the sender is a set of samples or anecdotes, which are drawn from the state of the world. So there's the state of the world there's some prior, say like Gaussian around the state of the world, whose mean is the state of the world. And then the signal is going to be a set of n samples drawn from that Gaussian. So this is what the sender has access to. The receiver doesn't see these signals, only the sender sees these anecdotes. And I'll also throughout most of the talk be working with us for what I call the foresight setting, where the sender also knows the state of the world precisely, but is restricted from communicating it because the sender can only communicate in anecdotes.
Can I ask you a question about the terminology of why I call this an anecdote versus evidence? Because usually when I think of anecdotal evidence, I think of that as being something that's not necessarily true. It's not a fact. It's something born out of a personal experience that may or may not be true. So it seems quite distinct from something that is immutable.
Yeah, I think anecdotes, that's a good question, and maybe we should consider this, but I have some examples here. So this is why I'm calling it anecdotes, which is you can look into the sort of analysis of political speeches. And this is actually an analysis that NPR did of Clinton's speech, one of her stump speeches. And this highlighting is NPR's, not mine. And the article in NPR was emphasizing that Clinton communicated primarily in her stump speeches through anecdotes. And here they highlighted this example where she heard this anecdote about two people working at some job, some like low paid job, and they were doing the same task, and the man was making $8.15 an hour and the woman was making $8 an hour. So this is an anecdote she presented about the gender wage gap. Why is this called anecdote instead of evidence? I think because it is a story that you pick up from your constituents and then report on, as opposed to like evidence might be statistics about the issue at hand, right? Like, the average woman in some particular industry makes 10 cents less on the dollar to the average man, which I'm not excluding. Like, you can also use those as anecdotes, but I thought it was particularly intriguing. And I feel like when I read newspaper articles, I do read a lot of very personalized stories, which probably have other points, like they're more relatable, things like that. But that's one reason we selected that word.
Can I ask also here, whether this could be lies? So is there any sense in which this anecdote, I think in your model, they have to be true.
Yeah.
And here, we the highlighted story could be just a made up story or a collection of different things that, creates a narrative, and it's an anecdote, but it's not reality. Does it matter in your model at all?
In my model, as I presented today, I'm going to insist that the anecdotes are samples from the state of the world. You could think about framing, which is kind of what you're hinting at, as so that there's a big long story she's stating here, which makes you kind of feel bad for the woman because now she can't go to college because she's not earning enough money, right? Like that's all kind of framing. And you could always in our model imagine perturbing I'll give the sender the ability to perturb the anecdote within a small interval. And I believe all of our results would go through. But I think what I really want to emphasize is how the restriction to communicate in anecdotes impacts what's communicated. And for that purpose, I'm going to restrict the sender to send precise true facts and can only send true facts. Also, I think that politicians and newspapers, I mean, in journalism, you even have fact checkers, and I guess we can argue about how much is news is false news, but I think for mainstream papers in societies like the United States, at least, there's still a lot of sort of forces that insist that the papers report facts, but that they can then maybe select out which facts they choose to report.
Sorry, you can finish.
I was going to give this second example of anecdotes, which is this newspaper, the New York Times. I selected the front page from May 2024, where they reported on the US deaths near 100,000. And then they listed out 1,000 people that had died from COVID at this point in time. So this could be an example of an anecdote, that US deaths near 100,000, which is a little bit more like evidence in Nageeb's terminology than anecdote. Yes.
Nicole, you're supposing here that the anecdotes come from the true distribution, right? So there's no bias in the generation of the samples. So I guess in practice, probably these companies ask for stories of a certain kind. So there's also bias in the sample generation. Is that going to end up being sort of equivalent to deciding whether, like, which facts to reveal, or would that actually be different?
I will need the facts to be single peaked and symmetric around the state of the world. But like you could have a heavier tail on one side than the other side if you want. So like you could be more likely to get negative evidence than positive evidence. It's important that there's a common prior about that distribution though. So like I might know that the New York Times interviews more people that are likely to have bad experiences with the gender wage gap, but it's still there's still mass on both sides.
Got it. Thank you.
So I'm going to focus on communication schemes in which I can only communicate a single anecdote. We can try to think about how this would change when we communicate multiple anecdotes, but for now, let's the paper I'm working on, I'm focusing on a single anecdote. And the questions I want to ask about this anecdote are, what anecdote gets communicated? Is there going to be bias in the anecdote that's communicated? And you might imagine that there would be bias because the sender wants to convince the receiver that the state is closer to our ideal point. So she might want to report anecdotes that are also closer to her ideal point. So we'll see this coming through. But the interesting thing is that the degree of bias in the equilibrium is going to be limited. And you also might ask about the amount of information that gets communicated. So what's the accuracy of the anecdote that is communicated? And we'll see that there is an incentive to report accurate information. We also are going to be interested in a question about which sender. We only have one sender in the model, but you could ask if the receiver could live in different worlds. Which world would the receiver prefer to live in? Would the receiver want to have access to a sender that has more preference alignment with the receiver, but has potentially access to less anecdotes? So maybe a novice type sender that's kind of aligned with my my preferences? Or would I rather have access to an expert sender, that is one who has many anecdotes, and thereby could communicate information to me more accurately, but is potentially misaligned with me and so has more incentives to try and persuade me? And we'll see that whether you prefer to live with a novice that's aligned or an expert that's misaligned depends on the shape of the distribution from which the anecdotes are drawn. So I'm going to focus on most of the talk on sort of Nash style solution concept, but we'll also look a little bit at the end, if there's time, at a Stackelberg style solution concept. So in the Nash, or like cheap talk, the sender and receiver are going to simultaneously make strategic choices, that is, simultaneously pick their communication scheme and the action rule that maps communicated information to an action choice. And each is going to be a best response to the other. In fact, I'll present it in this language, but the equilibrium that we end up characterizing does survive various refinements. So like it is a PBE, for example. Then we'll look a little bit at the Stackelberg setting, in which the sender first commits to a communication scheme, and then the receiver best responds to the commitment. And so the sender wants to commit to one such that the best response of the receiver is as good for the sender as possible. And the results we'll see in this setting are that there are going to be three main sections. The first section is going to be about characterizing the best responses of senders and receivers. So we'll see that when we're communicating with anecdotes, the sender is going to have a best response. We'll state some, we'll define some properties of strategies of communication schemes and action rules. And we'll see that the sender is going to have what we'll call translation invariant communication schemes, in which the anecdote that they send is the one that is closest to some predetermined shift of the state. So this would be like, I want to tell you about the story that's most representative of the state of the world -5. And then if the sender is using such a rule, the best response of the receiver is going to be to take an action which simply takes the state that the communication that they received and shifts it by some amount. And similarly, the sender's scheme will be a translation, will be a best response to an action of this form. So these are simultaneous best responses to each other. And that'll allow us to study this Nash equilibrium. And particular, we'll have a nice fixed point characterization of these the exact best responses, and we'll be able therefore to do some comparative statics about the bias of the schemes and the implications of preference misalignment. And then finally, we'll compare this to the setting where you do have commitment, and so the equilibrium scheme is unbiased and asymptotically in a setting, even when the sender does not know the state of the world, will end up sending the anecdote that's closest to the sender's posterior over the state of the world. So I don't expect you to absorb these theorems yet, but this is basically my outline slides. This is what we're going to go through in the talk. And before I do that, let me first introduce a little bit of the related work. So one thing that might have come to mind so far is this Crawford-Sobel paper, or the entire strand of literature on cheap talk, which generally says that signaling is more informative when preferences are more aligned, which we'll see in our setting as well. And also the form of the utilities that we work with in our talk are exactly like the primary example in the Crawford-Sobel paper with quadratic loss. So you'll see that in a minute. So there's a strong tie-in to this literature. There's also, of course, the results with commitment are going to be related to the whole line of literature on persuasion, where you can, that literature characterizes the optimal schemes with commitment and generally says that like there's no incentive to persuade if there's some sort of convexity of the problem, which our problem satisfies. So the fact that you're sending the most representative anecdote should be unsurprising given the context of this related literature in the Stackelberg setting. There's also a long line of work on selection where you're going to voluntarily disclose different facts. There's work from Grossman, Hart, and Milgram and Roberts, where like this line of papers shows that you get in some sense full unraveling. And then there's a lot of work trying to study settings under which you get partial unraveling in these voluntary disclosure settings. Typically in these papers, the information, the sender doesn't have a utility that changes with the state of the world. The sender is wanting to say, get the receiver to take a maximum action possible. And so this changes the incentives a lot because there's no longer any incentive for the sender to get the receiver to have some accurate beliefs about the state of the world, unlike in our model. So let me introduce the model and then I can go through the 3 sections of the talk that I discussed. I'm going to have 2 players, a sender and receiver. There's going to be a state of the world, which is drawn from a diffuse prior. That means it's equally likely to be anywhere. This can be made mathematically precise, but I won't be doing that in this talk. We're going to have ideal shifts. These are a shift of the state of the world that is the ideal action for the sender or receiver, respectively. And then we're going to have anecdotes. And these anecdotes are going to be drawn IID from a nice distribution, and nice here, like I need different conditions for different theorem statements. One sufficient thing would be that it's single peaked and symmetric and parameterized. like for example, like a Gaussian with mean theta and variance 1. I was saying to Annie, I could have different weights of tails on the two sides of the state of the world. I think that works. I wrote here symmetric because it's definitely sufficient. So these are sort of the components of my model. And now who knows what? So the ideal shifts are common knowledge. So there's no uncertainty. The receiver has no uncertainty about the type of the sender. They know the preference misalignment. And the number of anecdotes and the class of priors from which they're drawn. So like n anecdotes, and they're drawn Gaussian with mean theta. That's common knowledge. And of course, the diffuse prior of the state of the world is common knowledge. The sender, however, has private information about the state of the world in the foresight setting, at least. I'll relax that at the end of the talk. So the sender knows theta, the receiver does not. And the sender knows the anecdotes, these n anecdotes that were drawn from the state of the world, whereas the receiver does not.
Nicole, how do you think about the single peaked assumption in the context of the motivating examples? Because it seems like in a lot of those settings, we might expect the distribution of anecdotes to be, say, like bimodal, where you have like maybe two different groups or two different kinds of experiences.
Yes, so I can also, I think the results are a lot cleaner in the single peaked setting, because with the bimodal one, you might get more information by not sending the thing that's closest to the state of the world, because you want to, like, everybody knows it's bimodal, so I want to send something that's like centered around one of the modes so that you can then debias it accurately. So I think looking at other types of distributions from a what did we learn kind of muddies the math, but a lot of the intuitions feel like they should kind of follow through. Like, for example, that when you can commit, you just want to send the thing that gives the most information possible. And when you can't commit, you want to send things that are biased, like are moderately biased. I think those sorts of learnings, high level learnings, will survive other assumptions on the class of distributions.
Got it. Okay, so it's not super critical for the style of results that you're getting.
Yeah, but I mean, I haven't actually written that down, so take that with a grain of salt. So this is the strategies. I mentioned them in the beginning of the talk, but let me make this precise now. The sender is going to pick a communication scheme that maps the revealed anecdotes and the state of the world. I'm suppressing that, but the revealed anecdotes to a chosen one. And that chosen anecdote, of course, must be one of the ones that was revealed to the sender. And the receiver is going to select an action rule that maps the anecdote that they receive to a choice of what action they take. And all of this is on the real number line. The timing of the game, there's various timings that you could imagine, but just for clarity, let's fix one that works, which is that the sender and receiver are first going to select these functions pi and a. And so they simultaneously, in the case of the Nash, or sequentially in the case of the Stackelberg game, select the communication scheme and the action rule. And then the anecdotes are revealed, and mechanically the chosen anecdote is communicated, and mechanically the chosen action is taken. The payoffs,
Can I ask a question?
Yeah.
Sorry to interrupt. Just to understand. So the way I'm thinking about this is that you're getting a sample. These anecdotes are a sample from a distribution.
Yeah.
And when you don't commit, you report just one of these sample realizations.
Yep.
Whereas when you commit, you report some agreed upon function like the max, the min,
right,
the average. Right. But I mean, is there some restriction here? Because, for example, if these are finite number realizations, you might want to report the average, but that's not strictly speaking an anecdote in general, right? So are we going to look at order statistics? Are we going to look at medians and so on, or do you allow for more general functions?
No, you're required to communicate an anecdote. You can randomize over which anecdote you communicate, but at the end of the day, you must communicate.
What you're committing to is like the max, or so when I'm thinking.
Yeah,
of
you
it
have
as
to
cycle,
commit
but-
to something like the max or the third from, you know, the
right.
third.
So
from
an
the-
order statistic, in other words, something like that. Okay.
Yeah. You could also commit to something like the anecdote closest to some arbitrary point, say 0. Okay.
But just to make sure I'm on the same page here, I mean, you're formulating this in an ex ante formulation, but I often, for me, it's easiest to think about this as an interim formulation. Nature chooses a state. Nature chooses what anecdotes to give me. The set of messages I have available to me are the set of, I can choose any one of these anecdotes to communicate to the receiver. The receiver receives an anecdote, then the receiver chooses an action. Yep.
Yeah, I definitely prefer that formulation when I'm talking about the sort of what I'm calling Nash, in which case now I could even tell you that it's in that sequential form game, what I'm studying is actually a sequential equilibrium. The reason I write it with this timing is now when I want to talk about the commitment world, I find it difficult to explain what, like, it's just easier to explain commitment when I have this. Okay, so the payoffs are going to be quadratic loss. So the utility of the sender is the distance between the chosen action and the sender's ideal points, so squared loss, and the receiver similarly has a payoff that's like this, quadratic loss. And notice that both the sender and receiver are sensitive to the state of the world, so that the utility, this plays into both of their utilities, and this is going to drive some of the results. There's going to be what I've been calling Nash equilibrium concept, where the equilibrium profile that is the communication scheme and the action rule must be simultaneous best responses to each other. And I'll also then look at the Stackelberg, where the communication scheme is first chosen by the sender, and then the receiver best responds to it. So the sender picks the one that gives him the best utility when the receiver chooses her best response to it. Okay, so now let me get into characterization of best responses. I'm going to show you that these two sort of classes of communication scheme and action rule are simultaneous best responses to each other. And so let me start by defining the class of action rules that I'm going to study. I am going to say that an action rule is a translation if for any anecdote it receives, if that anecdote gets shifted by delta, then the action that the receiver takes is also simply shifted by delta. Okay, so notice for any action rule that's a translation, there's some constant shift. We're going to call it sigma for S for shift, such that for any X, the receiver simply takes an action, which is X plus sigma. And this is, I think, a nice class of action rules intuitively, because what's really going on here is that the receiver is debiasing the anecdote. So you can think that maybe this is what you do when you read a newspaper. You're like, this is the New York Times, it's a little bit left. So I'm going to take everything I read from the New York Times. I'm going to assume that it's like a little bit biased to the left, and I'm going to debias it. So these are translations. Actually, that's a class of action rules. Here's a class of communication schemes. I'll call them translation invariant. And a translation invariant communication scheme says, let's look at the set of anecdotes that are received. Let's shift all of them by the same constant delta. Then the one that you send is also just a shift by delta. And also, I didn't write the state of the world here, but I'm assuming that both all the anecdotes and the state of the world get shifted by delta, then what you send is also shifted by delta. And this is, I struggle a little bit more to motivate this as an interesting class of communication schemes, but I and my co-authors at least think that this is also kind of natural, because it captures the intuition that agents like senders are contemplating the bias of information. So like they're sort of having some kind of posture about what type of information they're going to communicate. And I also, this is sort of the motivation that I buy into, is that translation invariance is natural when you have a diffuse prior over the state. So numbers have no meaning. There's no specific meaning to the number 0 because the prior is diffuse over the state of the world. And so then why should you introduce a meaning to the number 0 in your communication scheme? So whatever, we can talk about what's the motivation for this, but the important thing is like, this is a class of communication schemes, and it happens to be a best response and hence part of an equilibrium, even in the broader world where you can communicate anything you want. That's an anecdote. Okay, so let's make sure we've understood what translation invariant communication schemes are. Here's some examples of a translation invariant communication schemes. One would be to send the minimum anecdote. That's translation invariant because if I shift this entire picture to the right, the minimum is shifted to the right by the same amount. I could also send the anecdote that's closest to the state of the world. This is also translation invariant because if I shift everything to the right, I shift this to the right by the same amount. I could send the third from the bottom. This would be sort of like the order statistic idea that someone was suggesting. Another thing I could do is, and this is going to be a subclass of translation invariant communication schemes that I'm going to focus on, is I could choose some target tau. I will choose the anecdote that's closest to the state of the world shifted by that target tau. Okay, so these are all different translation invariant communication schemes. What's not translation invariant would be, say, send the anecdote that's closest to 0. So another property that's going to be very useful in characterizing the best responses is the bias of a communication scheme. So I'll define the bias, beta of pi, to be the expected sort of bias in the random variable that is pi of, that is the anecdote that's sent minus the state of the world. Okay, so the bias is now the expectation over the anecdotes of the anecdote that's sent minus the state of the world. So to see an example of the bias, let's think about that communication scheme that I told you about, this one that uses some target tau. And let's see what the bias of this communication scheme is. So what's the expected bias of the anecdote that I'm going to send if I'm targeting something that's tau off from the state of the world? And this is where I'm using the single peakedness about the state of the world. The expected bias is going to be something a little bit closer to the state of the world because there's more density in the distribution over there. So you're more likely, when you're picking the anecdote that's closest to this vertical blue line, you're more likely to find one on the right than the left. And so the bias is going to be something just a bit closer to the state of the world than the target. And this gap between the chosen offset or target tau and the bias beta is going to be what's going to let us characterize the equilibrium. So this gap is what's going to become important. Okay, so with that sort of set of terminology, we've now learned what the bias of a communication scheme is. We've learned what a translation invariant communication scheme is, and we've learned what an action rule that's a translation is. Now I can tell you what the receiver's best response is to a sender that's using a translation invariant communication scheme. In particular, what the receiver is going to do is they're going to look at the bias of the communication scheme, and then they're going to debias what the anecdote that they receive and take an action according to that debiasing. And so the proof that this is a best response is really simple. You can just look at the receiver's utility function. Remember, it's that quadratic loss term. And so we're trying to say what A maximizes the quadratic loss, what action rule maximizes the quadratic loss. We can simply sub in the X minus the bias, so the anecdote that was received minus the bias of the communication scheme. This is now an unbiased estimator of the state of the world. And so the we can put it into the utility function since we only care about the posterior mean in the quadratic loss function, and then note that the action rule that minimizes this quadratic loss is simply to shift the received anecdote by the bias. So you debias the anecdote and then additionally move it over to the ideal point MR. So pictorially, if you prefer that, we have this chosen anecdote that was communicated. The receiver takes that communication, thinks about the bias of the communication scheme, shifts the received anecdote by its bias, and then adds the ideal point to select the action. So that's the receiver's best response. Now let's suppose that the receiver is using an action rule of that form, like a translation with some shift sigma. Then I want to claim that the best response of the sender is translation invariant. And so we're fixing the receiver to do something like we saw on the last slide, take the X and add some shift sigma. And what we can see is that what the sender is going to do, let's write down the sender's utility function. We see that the sender's action is, the sender is trying to minimize the distance between the action and her ideal point. We know the action is a translation, so we can sub in that. And then we see that this sender utility is maximized pointwise by selecting a communication scheme that is a theta plus the, so the state of the world plus some offset. In fact, we even know what that offset is. It's MS, the sender's ideal shift minus sigma, the shift that the receiver applies to the action, to the anecdote that she receives. And so this is what the sender wants to send. Now, this is not feasible point to send because the sender is restricted to sending anecdotes. And so we have to ask the sender to send an anecdote, and the best anecdote to send is the one that's closest to what she really wants to say. So in other words, her optimal communication scheme is a targeting scheme with this offset tau. And it's going to return an anecdote that's closest to this offset tau, where tau is MS minus sigma. Okay, so now we've solved for the best response of the sender and the receiver.
Nicole, just to clarify, can the sender choose to not send anything at all? And if the sender chooses not to send anything at all, what does the receiver do?
This could be another, if the sender doesn't send anything at all, and the receiver always picks minus infinity, this would be a sort of babbling-like equilibrium. And I'm not saying that this equilibrium is unique. I think if you, I've been trying to prove this, that if you require the sender to send exactly one anecdote, I'd like to claim that this thing I'm deriving is unique, but certainly if you don't require it, you can get dumb things happening.
I'm not sure this is a good time to ask, but it seems to me that the diffuse prior here is very important. Or in other words, if you had that the prior was another normal and then the signals were normally, you would have like a conjugate prior sort of construction, then this translation invariance would not apply, right? Am I right?
It is definitely very important. I think if you have a uniform prior over a growing interval, you'll still get results very similar to this with some error term, because it'll only become problematic at the boundaries. But this is, we're trying to think about the best way to like formalize our diffuse prior setup or motivate our diffuse prior setup. I agree that if you have something like Crawford-Sobel do, which is a bounded support prior on a unit interval where everything's like happening on the same order statistic as the length of that interval, you get a lot of issues with these boundary conditions. Okay, so I'm gonna skip this. These slides are suggesting that we could think instead about the sender, instead of picking a target, we could think about the sender as picking the bias of her scheme, and as the sender, as the receiver, like sort of interpreting the bias. But I'll skip that so that I can finish on time. I'm supposed to finish at noon, right? Or 15 minutes from now.
Yes, and then we have
Okay.
10-15 minutes for discussion.
Cool. So let me use this characterization that I've told you about to derive a description of the Nash equilibrium. And so recall the bias of the communication scheme is going to be the expected anecdote given that theta is 0. So we discussed what that looks like for these targeting schemes, which are the ones that we're most interested in. And as we discussed, the bias is just a bit different a bit closer to the state of the world than the offset chosen by the sender. And so this gap is going to be important in the characterization. And one thing you can notice right from the start is that the gap between the offset and the bias, so the gap between theta plus tau and theta plus beta, is going to grow as the target diverges from the state. And that's because when we're closer to the state, the distribution, it has more mass, and so there's going to be more anecdotes close to my target. So as when I'm right at the center, there's no gap because the scheme is unbiased. And as I grow out, I'm going to have the gap grow and grow as the target goes out into the tail of the distribution. Okay. And the rate at which this gap grows is going to be a function of the number of anecdotes that the sender has access to. That's pretty natural because if I have many more anecdotes, I'm much more likely to find ones close to my target. So the bias will be similar to the target itself. And so the gap is important because it characterizes the Nash equilibrium for me. In particular, I can prove that, and it's very easy to prove using the best response formulas I presented in the last section of the talk. You can prove that a strategy profile pi and a are a Nash equilibrium if and only if this gap that I've been talking about is equal to the preference misalignment. And then the action rule has the appropriate shift, okay? And so just first, why is this true? As I said, the characterization like that this equality needs to hold follows directly from the best response lemmas that I presented. And then why is there a solution to this fixed point equation? So this, now I'm going to use the niceness of the anecdote distribution. So it's this gap on the, fix the right-hand side, the gap on the left is 0 if tau is 0, and it grows without bound if the anecdote distribution is, and smoothly if the anecdote distribution is smooth. And so you're eventually going to hit this preference misalignment on the right. And so this equation has a solution. So fine, I think what's more interesting to me, at least, is what can we read out of this equation? And so here's some comparative statics that we can read out. So recall we're interested in when does this gap between tau and the bias equal the preference misalignment. If we fix the number of anecdotes, then the required offset, so the tau that you need, is going to grow as the preference misalignment grows. So if the number of anecdotes is small, then when my, in order to hit a particular gap MS minus MR, I might need some particular point in the distribution. And now if MS minus MR grows, I need to go even farther out in the distribution to hit that same gap, okay? So we're fixing the number of anecdotes. We're observing that the gap between the target and the bias of the scheme with that target is growing as the target diverges from the state. What about, so that's we're fixing the number of anecdotes and letting the preference misalignment grow. We could also ask what happens if we fix the preference misalignment and let the number of anecdotes grow. What happens to the offset? So if with a small number of anecdotes to hit a particular gap, we might need to go some distance out in the tail. And then when we have many, many more anecdotes, the gap grows more slowly. And so we're going to have to go much farther out into the tail. And so if we fix the preference misalignment, but as we grow the number of anecdotes, so as the sender becomes more of an expert, we get more and more biased data being sent to us as receivers. And so that allows us to derive some implications of these games. For equal experience levels, the receiver is going to prefer to communicate with a sender with more similar preferences. That was the first thing we observed. So if the equal experience levels is like fixing the number of anecdotes, then if the sender got to choose whether to have the receiver got to choose whether to listen to somebody who is similar to them or different from them, they would rather listen to somebody similar to them because that person would be sending them an anecdote that is less biased, and hence they would have more information, more accurate information with which to make their action choice. The other thing that this implies, these comparative statics imply, is that if there are different experience levels, that is, there's two senders which have different amounts of information about the world. Maybe there's a sender with like 1 million anecdotes and a sender with just a handful of anecdotes, then it could be that the receiver prefers to communicate with the less experienced sender who has more similar preferences. So I might prefer to talk to the person who has only a handful of anecdotes because because that person's going to send me an anecdote that's, say, closest to the state of the world, and that has a low variance because the distribution is very thick at that point. Whereas the experienced sender who has 1 million anecdotes but has a very different moral stance from me, or ideal point from me, is going to try to send me something far out in the tail, which has a lot of bias. And they have many, many anecdotes. So maybe the bias of the min of 1 million anecdotes is maybe the variance of the min of 1 million anecdotes is tiny, but it doesn't have to be. So in particular, if we're looking at Gaussian distributions, these have thin tails. And so even if I'm getting sent the smallest of 1 million anecdotes, because there's 1 million of them, I'm pretty confident about the state of the world. The variance of this anecdote is very tiny. But if I'm looking at a Laplacian distribution, so the anecdotes are drawn from something with a thick tail, you can set up examples in which even if the novice only has 2 anecdotes, the receiver would prefer to talk to the novice sender because the min anecdote in this type of distribution has constant variance. So this kind of, I find it interesting because it suggests, the first point on the slide suggests some sort of polarization, and the second point says that this type of polarization can survive even worlds in which there are experts out there that we could listen to, but we choose anyway to polarize to these novice people that have less information for us. Okay, so let me switch tracks slightly and talk about this other type of equilibrium you could be interested in, which is this Stackelberg one. So now we have the ability for the sender to commit to the communication scheme. And what we'll see is that the scheme is unbiased, which is maybe not super surprising, especially, you can write it down in one line that the sender wants to send the most representative anecdote. But I think what I find, the reason I wanted to show you these results anyway is because it illuminates one of the problems with the sender not knowing the state of the world. So let's see how this works. First, I'll skip the point that the proof that the sender wants to send the most representative anecdote if she can commit to her communication scheme. But notice that the most representative anecdote requires the sender to know theta. So if the sender knows the state of the world, then what she wants to do is send the anecdote that's closest to the state of the world. But if the sender doesn't know the state of the world, then the tricky thing that happens is that the anecdotes that the sender receives correlate with her posterior. So let's look at an example to see why this is problematic. Let's suppose that the anecdote distribution is uniform in a unit interval centered at the state of the world. Okay, this isn't single peaked, but you can make it slightly less than uniform if you want it to be single peaked, doesn't matter. Okay, uniform centered at the state of the world. Now I'm drawing 3 anecdotes. So n is 3. Okay, so what is the posterior of the sender? What is theta s? So with the sender now, I'm in the world where the sender doesn't know theta. The sender only sees the anecdotes, must form some beliefs about the state of the world based on the anecdotes she observes. Well, her belief is there's 3 anecdotes drawn from a uniform distribution. The middle one doesn't matter. Her belief is the average of the min and the max. That's theta s. And then conditional on the min and the max, the middle one is uniform between the min and the max. So the closest, the sort of most representative anecdote that we claim is optimal if the sender knows theta, the sort of natural interpretation of that in the world where the sender doesn't know theta is to send the closest to her posterior, theta s. But this is clearly in this example not the most informative. It would be much more informative to send one of the extreme anecdotes, basically trying to get the receiver to understand where this distribution drops off. And so the sender doesn't necessarily want to send the anecdote that's closest to her posterior, but we can prove that that's true in an asymptotic sense. So the way we do this is we're going to pick so this is like the proof technique. So now I'm trying to argue that I want to send the anecdote that's closest to my posterior when I can commit, even asymptotically as the number of anecdotes grows. So what I do, and the problem, recall, that I'm trying to avoid is that my posterior correlates with the anecdotes that I receive. So I'm going to pick a small sliver around my posterior, and it's going to be small enough so that it doesn't contain any anecdotes. And then I'm going to pick some medium-sized slivers to the left and right of my posterior. And within these medium-sized anecdotes, I can rearrange, I can redraw the anecdotes. And this has minimal impact on my posterior. So when I redraw these anecdotes uniformly from these slivers to the left and right of my posterior, nothing changes much about my posterior. And now the density of anecdotes in these slivers is approximately uniform. And so I can calculate the signaling loss of this closest to shifted posterior for any scheme. And that lets me get an asymptotic result. And the error term is now going to be related to the fact that I had to redraw these anecdotes in these slivers and assume that it didn't change my posterior. And so this scheme, which sends the anecdote closest to my posterior, is we can calculate the signaling loss with this error term. And we can also calculate the signaling loss of any other communication scheme, also with an error term. And then what you can see is that for a large enough n, the scheme that sends the anecdote that's most representative of my beliefs is going to outperform any other scheme for this sender with commitment. So that was a little fast, but I guess like what I want you to get out of that section of the talk is that this assumption of foresight is actually important. Like the fact that the sender doesn't have to form beliefs about the state of the world, but knows it precisely, does impact the way the communication scheme works. And nonetheless, we can resolve that asymptotically for the Stackelberg setting. And I think that same sort of technique with these slivers and redrawing the anecdotes is going to also enable us to resolve this for the Nash equilibrium. And hence, even if the sender doesn't know the state of the world, we can still calculate approximate Nash equilibria and have the same sort of comparative statics that I showed you in that section of the talk. So let me wrap up the talk. So what did I talk about? We talked about communication with anecdotes, and we saw that this results in information loss naturally because I can't communicate an arbitrary piece of information. I can only communicate an anecdote, and anecdotes are noisy inherently. And this information loss is less so if the sender can commit. And why is that? That's because if the sender can commit, the sort of temptation to persuade washes out, and the sender now is most concerned about communicating accurately. And so the most accurate thing the sender can say is has the lowest possible information loss, that's lowest variance. And so the receiver gets more information here if the sender can commit. And in this commitment scheme, the sender is going to pick the most representative anecdote, that is this anecdote that's closest to the state of the world. Or if the sender doesn't know the state of the world, the anecdote that is closest to the sender's posterior about the state of the world. Posterior mean. Without commitment, the sender is going to pick biased anecdotes, but not arbitrarily biased ones. In particular, if I fix the number of anecdotes that the sender has access to, the bias of what the sender says grows with the preference misalignment. And if instead I fix the preference misalignment, then the bias of what the sender sends is going to grow as the number of anecdotes grows. So as the sender becomes more of an expert, they also become more biased. And that means that for some priors, such as Laplace, priors with heavy tails, the receivers would prefer to communicate with less informed senders. And then I think that sort of leads us into an interesting direction for future investigation, which is I've thus far focused entirely on a single receiver and a single sender. But what if we had a population of agents, all of whom have access to some anecdotes, and they engage in random conversations? What sort of information flows happen, who talks to whom, and how do the beliefs and actions evolve? So with that, I'll conclude my talk. Thanks for listening.
Thank you very much, Nicole. Annie, do you have any comments, questions, and then we can open to everyone else?
Yeah, sure. So first, nice talk. So I agree the dropping foresight in the Nash equilibrium case would be interesting. Because I especially liked the comparative static and the number of anecdotes. But in a sense, it's not exactly fair to call that like expertise, right? Because you already know theta. So in a sense, the number of anecdotes, it's just, it's more of a measure of flexibility in what you can say. But it's not that you actually understand theta better, right?
That's a good point, yeah. Yeah.
So yeah, it'd be cool to see how those forces balance out in that case.
Yeah.
Yeah. Do you have conjectures? Or do you, because you said something at the end, right? That you thought.
Yeah,
that...
I'm thinking about this now. So I think the proof technique we have for the Stackelberg setting will apply to the Nash setting, but asymptotically. So now, I guess the statement would be like, first of all, I guess your interpretation is interesting to me, that if I'm more, like I'd prefer to talk to a less flexible person that's more similar to me than a more flexible person that's less similar to me. Like, so you're changing my statement about expertise with a statement about flexibility. But if I want to say something about expertise and work with posteriors, I'll be able to make comparisons between like moderate experts and extreme experts. Like I need the N to be large enough for that proof technique to follow through. But it will, so long as the N is large enough.
Okay. I'm happy to let other people ask questions.
Yeah.
Maybe I can ask one question. So if we were to do something like a dynamic model where the sender would actually send several of this evidence, so eventually the true state would be revealed. So that would be, is this something that will happen or not? Or you would just...
I mean, if I'm only allowed to communicate anecdotes, then the best I can do is send N anecdotes. Are you also redrawing the anecdotes every period?
No, so I guess you only allow
Yeah, so we could study this, game, this where first nature draws n anecdotes, then the sender sends one, and then the receiver takes an action, and then the sender sends a second one, and the receiver takes an action. Is that what you have in mind?
Yes.
Yeah.
There could be a model in which you are free to choose the number of anecdotes you send. So it's not dynamic. It's like your model, except the choice is not one.
That's another setting to look at. The first thing that was mentioned, I'm trying to imagine what the payoffs would be, because now there's multiple actions. So I guess I could study that. There's some choices to make. I'm not entirely sure what conclusions I would draw, but at the end of the day, I'm not going to completely learn the state of the world anyway, because the best I can do is learn all the anecdotes as the receiver. And then the other question about what if I can choose how many anecdotes to reveal, I'm worried you might now get some sort of unraveling effect in the Nash. So in the Stackelberg setting, you'll reveal everything, because the only thing you want to do in the Stackelberg setting is minimize the variance of the receiver's posterior mean. But in the Nash equilibrium, I think if you hide one of the anecdotes, the receiver you might get this standard sort of unraveling argument where the receiver assumes the worst news about the thing you hid, and then you're compelled to reveal it.
Mm-hmm.
But isn't it the case for the case of several signals, okay, that can be sent by the sender? This unraveling result is not similar to basically the answer you gave to Nageeb question, okay, of whether, is there an option of not sending a signal at all, okay? And then basically you say, look, I can basically just assume that or construct an equilibrium in which they believe you receive nothing is basically the worst possible, okay? And that's the reason why you always send one. But isn't it the same when you have several signals, okay? You basically, if you don't send all the ones that you could potentially send, okay, you send something less, you basically put the beliefs in the worst possible case, okay? And that's the reason why in equilibrium you always reveal all the signals that you have, which I believe is a case that you could analyze, no, with your technology.
Yes, I'm unsure exactly what you're saying. Like, there might be many equilibria, right? And so if I can send any number, sending nothing, so the pi is the empty set and the A is minus infinity, should be regardless of what's sent, should be an equilibrium. And now are you saying there should also be an equilibrium where I send just one anecdote, and if I ever send two, the pi is the receiver takes some bad action to make sure I
was actually thinking the opposite. If you can send up to two, okay. If you send less than two, then basically the beliefs are, which is exactly the answer that you gave to Nageeb's question, no? For the case of sending no signal at all.
Yes. Yeah.
The question here is if this is a free choice. So it's not only the location of the anecdote you pick, but also the number, how many of them, without any external penalties for sending it. So there is no cost to the number.
Yes. Yeah, we rely on, you can either get this sort of agreement in us because it's an equilibrium to agree because the receiver is going to blow up the world if I don't send exactly one, and thereby get exactly one to work, or you could also have equilibria where if I don't send it, where I'm compelled to send as many as I'm allowed to send.
I have a question, but if there are other people who want to ask, Arda, go ahead.
Yeah, can I ask you? So these comparative statics you have with respect to bias, do you have similar comparative statics with respect to the average or expected distance between the state and the action taken? Or
I think that should be implied in some of what I said. Yes, let's see. I think that, so the action is always debiasing first, so that the sender correctly debiases in any equilibrium the signal that was sent, the communication that was sent, so that the expected distance of the action to the state of the world, I believe, should always be MR. But what will change is the variance of the action.
Okay.
And the variance of the action will get much worse as the variance of what's sent gets worse, which happens as we get further out into the tail.
Okay. Thank you.
Let me ask this question. At certain point at the beginning, you had this tool sets up, that you call it Nash equilibrium and Stackelberg, and in the brackets in the Nash you said cheap talk, and it kind of threw me away, because this is not really a cheap talk if you have only evidence presentation. So I was thinking about this comparative statics. I think you have it second to last 3 dots as bias. As the number of anecdotes grow. As number of anecdotes grow, something fundamental changes, because we are getting closer to cheap talk again. You have more freedom to pick anything you want, and then restricting the number of anecdotes, we are getting closer to, yes, there is a loss in the flexibility of what you can do, and that's restricting, but also it gives you a bit of commitment, not commitment power maybe, but even in the Nash equilibrium game, it becomes more of a hard evidence type of model. And
yeah.
That's the critical tension I think would be worth maybe, I don't know, it's about framing really, not the results, because results are there, but.
Yeah, no, that's very perceptive. The parenthetical cheap talk was a sort of holdover from the days when I wanted to look at this as the limit of my model as n grows as Crawford-Sobel. I kind of backed away from that because it became difficult to think about what Crawford-Sobel would even say in a model with diffuse prior like this, and so I wasn't quite ready to go there, and I just didn't remove it from the slides. But I guess your framing of talking about this as sort of as n as a commitment power is very interesting. Like as n is small, I have more power to commit to things because there's only a small number of things I can say. I hadn't thought about it in that direction. Yeah.
So which raises kind of a question for a sort of a generalization, because there's an n that restricts, but okay, how about other restrictions? So you could. So it seems like there's a technology out there. You commit to that as a researcher. You commit to that technology, that only those ways of communication are possible. But maybe there would be a way to kind of generalize. Now I'm just saying things out loud.
But I do like the idea that the number of anecdotes you have available is sort of a measure of the distance between cheap talk and hard evidence in a way, right? Which is because typically you think of these as two extremes. One, there's no cost of lying. The other one is an infinite cost of lying. Whereas here, what you have is somewhere like, of course, your results are then, they're not really, if you have this many anecdotes, then this is what happens. You have this other many, but you do have a comparative static as they increase. So that I think, particularly for an economics audience, is would be an interesting observation. Can I ask? I was going to ask, is it obvious that if you allowed for investing in anecdotes, so if I could exogenously choose, perhaps at a cost, to buy one more anecdote and so on. So it seems to me that your result on whether the distribution is at a plus or a normal is interesting there as well, because it will only reinforce that point that perhaps if you're dealing with a plus, you don't want to do the investment at all. You want to get one anecdote and that's it. And is that right? So
yeah, because so the sender is the one investing in the anecdotes, right?
yeah.
And then the sender would, like, the sender likes to be able to send more accurate information because that reduces the variance, which negatively impacts her utility. But at some point with Laplace, there's no point in investing. And in fact, you don't want to even start the investments because like your variance gets, I guess, yeah.
But maybe actually, now that I think about it, in the other example, you want to be more precise, but then the cost accumulates. So but that's more standard. That's like it's like a walled story. You at some point you don't want more samples, observations, because they're too expensive to get for the amount of information that you're likely to learn. So that's true. But yeah, but I mean, there is this interesting. I mean, it reminds me of this recent paper by Ottaviani, Sorensen, and Dittilio. There seems to be this in econometrica, this relationship with that paper where they look at whether it's better to have an unbiased sample or to look at something where you look at the maximum of a distribution. I can't quite put my finger on the relationship, but it kind of smells. Probably this is the sort of comment I should make when it's not being recorded, but because it's extremely hand-wavish, but there seems to be a relationship there, which I can't put my finger on.
It's definitely like, there is definitely that element here too, that like this comparative static depends very much on whether the max gives you more information than like a single sample. Yeah.
Nicole, unfortunately, I have to run, but thanks again for the talk.
Yeah, thanks for coming.
Thanks.
Thank you, Annie. Thank you.
It's time to finish, I think, the recording.
Yes, we should have. Okay, it was very nice talk, Nicole. So when you initially sent me the title of the